Welcome, my geometry friends, to our last lesson 1 video. We're going to take what we've learned and learn and define perpendicular bisectors and learn how to construct them. What you're going to need are your notes, and you also probably want your Chromebook at some point. So our big idea for today is perpendicular bisectors, how to define them, and learning how to construct them. So remember, we've used our handheld compass and straight edge to construct circles and segments, and we've used the GeoGebra digital applet to do the same. And so today, to do that construction for a perpendicular bisector, we're going to need to know how to construct a segment, and then to use circles made with our compass to find the perpendicular bisector. But first, let's make sure we understand what a perpendicular bisector is. Recently, we went outside and we stood between 2 trees in front of the high school. These are not the trees we stood in front of, but they were similarly spaced. And we took those trees and everybody looked at the trees and found one spot to stand where they felt they were exactly the same distance from each tree. So the first person, pretty easy, right there between the 2 trees in the middle. But the next person, right here, and then the next person. And you notice how they're about, these distances are the same. They're trying to get the same distance from the tree. If this was all ground and we're going over here, same distance. And what happened when we did that? Well, what happened is that we formed a line, a straight line, between the 2 trees, and that straight line was actually a perpendicular bisector. If we had connected the 2 trees and drew our line, we would have made a perpendicular bisector. So let's look at that definition. You need to add the following definition to your notes. This is the first definition we've added without a handout to guide us. So let's talk through that. On the next open page in your notes, you're going to want to write the word perpendicular bisector. You're going to want to write the definition from this slide, or put this definition in your own words that makes sense to you. And you will always want to draw a picture that shows you what that word means. So a perpendicular bisector is a line through the midpoint of a segment that is perpendicular to that segment. So midpoint, we take the beginning, the prefix, and mid means middle. So if I have a segment here that I will call PQ, I want to find the middle. It's going to be halfway between the 2. So this side and this side are the same length. So the first part of perpendicular bisector is the bisector part. It's the midpoint part. The second part is it's perpendicular. So it's going to cross the line at a 90-degree angle. So when we have this little square mark I made, that tells us that it's at a 90-degree angle. And that is what indicates a line is, our 2 lines are perpendicular to each other. They're at 90 degrees. They cross each other at 90 degrees. So this example I've drawn is a perpendicular bisector. Notice that the second one, segment AB, it's a bisector, but it is not perpendicular. So that is not a perpendicular bisector. And then notice the third one over here from FG. Notice we do have the perpendicular line, but it's not in the middle. The middle would be somewhere over here. So it again is not an example. So I've drawn an example of what is a perpendicular bisector, and then we have 2 examples of what's not to show you what's not. And I also want you to add this following theorem to your notes. Just underneath the perpendicular bisector definition, on that same open page, you'll put a title that says Perpendicular Bisector Theorem, and you'll include these words that I've got on the slide, or put that in your own words that make more sense to you, and you'll want to include the picture. So if a point is on the perpendicular bisector of a segment, that means if a point is anywhere on this perpendicular bisector, this D to C, that segment is cutting AB in half, and it's perpendicular to AB. So if any point on that segment DC, then that point is equidistant, same distance, equally distant from the endpoints of the segment, from A and from B. So our red dotted line, that red dotted line is equal to that red dotted line. The segment AF is congruent or equal to the same distance as BF is. F is the same distance from B as it is from A. We have the same thing here, 1, 2, 3, 4, different number of tick marks, tell you they're different sizes, and so on. So we've got the definition of a perpendicular bisector. We have the perpendicular bisector theorem. And I have two videos I'd like you to watch. One, how to construct a perpendicular bisector by hand. Two, how to construct a perpendicular bisector in GeoGebra. They're both very short. You'll watch those two videos to see the actual constructions. And then you're ready to practice. You'll need to practice the perpendicular bisector construction. Practice it both ways, and then pick the way you like best and practice some more. So practice with paper, pencil, compass, straight edge. Then practice in GeoGebra. And when you've practiced both, then decide which one you like best and do a little bit more practice. Then you'll want to review your notes and the definition of perpendicular bisector. And when you've done that and you think you're ready for the mastery check, come get the mastery check from me, and we will get you started.